All right, we're going to start with problem 8-2. You're going to need a resource page for this problem, so please find the resource page in the FidDay folder for March 30th. And the lesson resource page is 8.1.1a. You're also going to need B as well. So you might as well pause the video and put both into Notability. All right, hopefully you're ready to go now. It says, now that you have predicted what different graphs look like, we will look and investigate how some of the measures are related. To start, consider this situation. Oscar puts $1,000 of principal into a bank account that earns 2% simple interest each month. He wants to track how much money is growing over time. So there's a couple different ways that we can talk about simple interest. Simple interest is interest you can pay on an amount of money you borrowed. So like if your parents talk about their mortgage payment, they pay interest each month on top of what they borrowed to pay for their house. Interest could also be for like a car loan, but you could also invest money. When you invest money, that means you're saving money. So it says, Oscar is using the formula at the right to calculate how much interest will he earn on his investment that are earning simple interest. He knows that the simple interest is paid only on the original amount that was deposited. So the original amount deposited here is the $1,000. Okay? And the original amount deposited is called your principal. So the P in this equation is $1,000. Okay, I'm looking here at the formula. The interest, we don't know because that's the output, what we're getting as our final solution. The rate, we do know, and it's 2%. But if we know what percent is, it's always out of 100. So our rate is really going to be 0.02. Because 2% out of 100, 2 over 100 is 2 hundredths as a decimal. And our time, T, is going to be however many months he's going to be saving. So if we wanted to calculate how much he would have in 1 month, we would use a 1. So on your resource page, you have this table, and his account balance is $1,000 right now. And if we want to know how much he's going to have, we would do 1,000, going back to that formula, times 0.02 times 1 month. So if you have a calculator on your iPad, go ahead and calculate that. If you have your own calculator, please do it, or use your phone calculator. But 1,000 times 0.02 times 1 is going to come back as $20. So after 1 month, he would have earned an extra $20. So for month 1, total interest earned, it was $20. So think about it. He's going to gain 20 every month. So month 2, he would have 40, 60, 80, and 100. Okay? So then we want to find the total amount that he has in his bank account. So at the end of that first month, he would have 1,020, 1,040, 1,060, 1,080, 1,100. So if I wanted to use the formula to just find maybe if I added a value to my table here at 20, I would change that 1 to be 20. So I would use 1,000 times 0.02 times 20, and that would give me the amount that he would earn extra on top of the $1,000 after 20 months. Please do it on your calculator. Hopefully you got $400. So after 20 months, he would have $1,400 in his savings account balance. Now we're going to graph this information onto a graph. that's underneath your table, and the graph shows time in months versus interest earned. So we're going to be graphing the time in months. We're going to be graphing the months and the interest, not the bank account balance. So the months is going to be my X, and the total interest is going to be Y. Go ahead and pause the video, make your graph, and then compare it to the graph that I have that I'm going to show you. So this is what your graph should have come out like. When we looked at our table, we saw that it increased by $20 every month. So after month 1, he had $20. After month 2, he had $40. So that's a constant rate. So we should see that our graph has a constant rate and makes a straight line. So check yours with this one and make sure that it looks like mine. And then we're going to move on to problem 8.3. Again, if you need to pause, go ahead, or if you need to rewatch any part of the video before we move on, go ahead and do that. 8.3 says, profit, profit, profit. Anita bought a special baseball card for $8. Later, she decided to sell it, but she wanted to make a profit. She added 50% to the price that she paid and sold the card to Brandon. When he decided to sell it, he also wanted to make a profit, so he added 50% to the price that he paid and sold the card to Casey. Casey increased the price by 50% and sold the card to Eli, who increased the price by another 50% and sold it to Fernanda. On the resource page 8.1.1b, we're going to be filling out the table for this problem. So again, you need that resource page. If you need to pause the video to find it, please do so. But we're going to take a look at it right now. All right, so first price was $8. That was Anita. Anita bought it for $8, but she's going to sell it to Brandon, and she's going to sell it to him for 50% more. So what is 50% of $8? Or what is half of 8? Half of 8 is 4. So she's going to price increase the item by $4. But the new price is not going to be $4. The new price is going to be 8 plus 4, which is 12. But remember, Brandon then wanted to increase the price and make a profit when he was selling it to Casey, and he wants to sell it for 50% more than he paid. So what is 50% of 12? What's half of $12? It is 6. So he's going to increase the price by $6, which means he's now not going to sell it for 6. He's not going to sell it for 8. He's going to sell it for the price he paid, which was 12, plus the $6. So he's going to sell it for $18. If we go back to the problem, it says that then Casey increased the price by 50% and sold it to Eli. Eli also wants to make a 50% profit. So half of 18 is 9, and 18 plus 9 is 27. Eli wants to make a 50% profit and sell it to Fernanda. You should be writing everything I'm writing. Half of $27 comes out as a decimal. It's $13.50. So she's going to pay a total of $40.50. Fernanda was the last person in line, but the chart would like us to go to the 5th person. So if Fernanda would sell it for a 50% increase, she would take half of $40.50, and that's $20.25. That's how much more she would charge the next person. So that next person would pay $40.50 plus $20.25, which is $60.75. So we could keep going to see how much it increased by, but you can see each time it didn't increase by a steady amount or a constant rate of change. So I'm hoping you're thinking that, well, this graph's not really going to make a straight line. No, it doesn't make a straight line. It's called an exponential function, and it makes this curved line. So this is called an exponential function, and it does not make a straight line. The first graph we did was a linear function because it made a straight line. This one is exponential. And those of you who had me last